Hey everyone and welcome. Today we're going to crack open one of the most fundamental tools in any programmer's arsenal, functions in C. Seriously, think of these as your first real programming superpower. They let you write code that's cleaner, way smarter, and just so much more powerful. Okay, let's get into it.
So if you're just starting your coding journey, you have definitely felt this. You figure out how to do something, and then, like 20 lines later, you're typing the exact same logic all over again. It's clunky, right? It gets messy, and honestly, it's just asking for bugs to creep in. But what if there was a much better way? And this quote just hits the nail on the head. I mean, think about it. When you need the square root of a number on your calculator, you don't grab a pencil and paper and re-engineer the whole mathematical process. No way, you just press the button. A function is exactly that. It's a reusable button you build for your code.
So how do we actually build these code buttons for ourselves? Let's break down the blueprint, the actual anatomy of a function, so you can start making your own.
At its heart, this is all it is. A function is just a self-contained package of instructions that you give a unique name. So instead of writing out those instructions every single time, you just call it by its name. It is the ultimate work smarter, not harder tool in programming, for sure.
Now, functions kind of come in two main flavors. On one side, you've got your built-in functions, like printf. C gives you these tools right out of the box. They're pre-made and ready to go. But on the other side, and this is where the real magic happens, we have user-defined functions. These are the ones you create to solve your specific problems.
Creating your own function is a lot like writing a recipe. It's a simple three-step process. First up is the declaration. This is basically a promise you make to your program saying, hey, a function with this name and this purpose exists, I promise. Second is the definition. These are the actual step-by-step instructions of your recipe. And finally, you have the call. This is the action, where you tell the program, okay, go run that recipe right now. Great, so we can make these reusable little blocks of code. But how do we get information into them, and how do we get results back out? Let's take a look at how functions actually communicate.
Well, if a function is a recipe, then parameters are its ingredients. See, when you call a function, you can pass data into it. This is what makes your function so flexible. A function to add two numbers isn't stuck only adding, say, 5 and 3. You can give it any two numbers as ingredients. And after your function has worked its magic with the ingredients, it can give something back. The return statement, that's like the finished dish coming out of the kitchen. Your add function takes two numbers as parameters and it returns their sum. It's the result you're looking for.
Okay, now this next part is absolutely crucial. There are two main ways to pass those ingredients in. Call by value is like sending a photocopy of your data. The function can write all over that copy, but your original document is perfectly safe. Call by reference, on the other hand, that's like giving the function the actual address of your original data. It's way more powerful because it means the function can directly change your original variables.
All right, enough theory. The absolute best way to really understand functions is to see them in action. So let's look at some practical code examples. So for our first example, let's imagine a function whose one job is to calculate a factorial. You know, where you take a number and multiply it by every whole number below it down to 1. We just wrap all that logic up in a neat little block of code. And there it is. We give it the ingredient 5, it runs its recipe behind the scenes, and boom, it hands back the finished dish, the number 120. It's simple, it's clean, and now we have a tool we can reuse to find the factorial of any number we want. Next up, a classic programming puzzle. How do you swap the values of two variables? This is the perfect job for a function. And to make this work, we're going to have to use that call by reference method we just talked about, giving the function permission to directly change the original variables.
And just look at the payoff. Before we call the function, a is 10 and b is 20. After one single simple function call, they're perfectly swapped. This just goes to show you how a function can hide a bunch of steps behind one simple, readable name.
For our last example, let's try something a little more complex, a function that checks if a number is prime. Now, the logic for this can get a little tricky, so packaging it up inside its own function is a fantastic way to keep your main program tidy and easy to read.
And the results are exactly what you'd expect. We give it the number 7, it does its checks and tells us, yep, it's prime. We feed it the number 10 and it comes back saying, nope, not prime. We've built another reliable, reusable tool for a very specific job.
So after seeing all that, let's just step back and look at the big picture here. Why is this so important? Well, this is where you really unlock that programming superpower we mentioned. Let's talk about the payoff.
It all boils down to these 3 huge benefits. First, code reusability. Write it once, use it forever. Second, improved readability. Your main code becomes a clean, easy-to-follow story. And third, modular programming. This is a huge shift in thinking. You stop writing one long, messy script, and you start designing solutions by breaking a big problem down into smaller, manageable, function-sized pieces.
And that really brings us to the end. You now have the blueprint to create your own powerful, reusable blocks of code. So the only question left is, what problem will you solve with your first function? Thanks for joining me.